Hello and welcome to this video. From now on, we will start with data structures and algorithm. In short, it is also called as DSA. So we will start with linked list. Linked list is a linear data structure and it stores the data as similar to array. So there are two types of linked list. The first one is singly linked list and the second one is doubly linked list. So we have two types of linked list. The first one is singly linked list and the second one is doubly linked list. So here is a representation of singly linked list. So the singly linked list will have a head and the head pointer will point to the first element of the linked list, and this element combines together called as a node. So here is a representation of node. So the node will have a two blocks, and in the first block of node it will stores data. So here you can see it has store 5, and the next block will store the address of next node. So here you can see the head is pointing to the first node, and the first block is storing the data which is 5, and the next block is storing the address of the next node, and it is represented by using an arrow. And also you can see then the next node is storing 3, and the block which is attached to the 3 is storing the pointer to its next node. Now the last node will store the null value. So if we have to attach any next node to this, for example, if I want to attach this, then I will remove this node. For example, I will remove null from this, and then I will point this arrow to this next node. That means now I have added a node successfully to it. Then what I have to do, I have to add some data here. Let's say I have added 44, and after that one more thing is remain. I have to add null value in the next. So this is how we can create a next node and add value to it. So this is singly linked list. So let us see doubly linked list. I will remove this first of all. Yeah. So in doubly linked list is very much similar to the singly linked list. But the only difference is, as in singly linked list, the next pointer is pointing to the next node. In doubly linked list, the next node will be pointing to the previous node. So we will have a two pointer. For example, so we have head, then we have the next node, and the next node will point to the previous node like this. Similarly, this node will also point to the previous node. So this is how we can represent a doubly linked list. And if I want to add this element to the last, then what I have to do? I have to first of all erase the null. I will erase the null, and then I will point this node to the next node, which is this, and also this node will be pointing to the previous node. So this is how we can add the next block. And also we have to write null over here, and also the data, let's say 88. I will move this over here. So this is how we can add data element at the last in a doubly linked list. So in a singly linked list, we have all the arrows pointing to the next element. So while traversing the singly linked list, I can only traverse through starting to the end. For example, if I start from the head, then I can go to 5, then I can go to 3, 8, and then 88. But I cannot reverse traverse this list. I cannot go to the previous element. But in a doubly linked list, as we are pointing to the previous element, I can traverse to the previous element, because we have the pointer which is pointing to the previous element. That is why we can traverse in a reverse manner also. This is the next arrow, and this is the previous. So by using next arrows, we can traverse in a forward direction, and by using the previous pointer, we can traverse in a reverse direction. So this is how doubly linked list can be used to traverse in both direction. For certain examples, it will save us more time, because we have a way to go to the previous element. So let us go to a PyCharm window and let us try to create a singly linked list first. Let us close all the previous work. I will create a new directory for our TSA. Create a new Python file for singly linked list. So singly linked list has a node. I will write that down over here. It has a node. Then we have a head. So these are the two main element of the linked list. So let us start and try building a node. So I will write a class for node, class node. Now I will initialize a node class. So dev underscore underscore init. I have to store the data. So I will write data. So in order to move to the next element, we have to write a pointer to next. So that is self dot next. So let us initialize it to none. Then we have to store data. So I will initialize data with the data we have passed while initializing the node. So as we have seen in the diagram, we have a node and the first block has a data and the second block has the pointer to the next node. So here we have written, we have the next and then we have a data. So data will store the data and next will store the address of the next node. We can also exchange their position. So data is at the first position and the next will store the address to the next node. So let us create a single linked list. I will write a class for head. So I will name it as linked list or a single linked list because we are creating single linked list right now. Single linked list, so it will be more easy to understand. Then I will initialize it and single linked list will start with head. So I will write self dot head and it is not pointing to anything, so I will write none over here. Now let us start building a single linked list. So I will initialize a node named A with values. I will take the values from our list, which is 5, 3, 8 and then 88. So I will initialize A with 5, then B node 5, 3, then C with 8, then D with node 88. So we have initialized all our nodes. Then we have to use single linked list to connect them all. So let us try that. Initialize a single linked list name SLL. So SLL equals to SLL. So I have initialized our single linked list. So we have initialized our single linked list. So I will make A as our head. So I will point our head to A. So how can I do that? So SLL dot head is A. So now our head pointer is pointing to A. That is our head pointer is pointing to 5. So this is how we can represent that. Now our A, that is 5 is pointing to 3. That is 5 is pointing to 3. So I will write A dot next equals to B because the next is pointing to the 3. So here the 3 is represented by B. So A dot next is B. So similarly B dot next is C. Also C dot next is T. So we have written all the nodes, that is 5 is pointing to 3, 3 is pointing to 8 and 8 is pointing to 88. So A dot next is pointing to B, which is 3. Then B dot next is pointing to C, which is 8, and C dot next is pointing to D, which is 88. So in this video we have created the linked list successfully. So in the next video we will see how to traverse through the linked list. So thanks for watching this video and I will meet you in the next one.